Well, hey there, kiddos, and welcome to your very first video about quadratics. You're going to start out today. I gave you a book in class today. You need to take those 2 pages and fold them together. I hope that you didn't separate them because they are in the order they need to be. So you take your 2 pages, fold them together, make a book, and this should be what's on the front. So we're going to start by talking about what the parts of a quadratic are. What a quadratic function is all of those polynomials you have been factoring for the last 2-3 weeks. Are what are known as quadratic functions. All of those x squared plus 2x plus 6 kind of things going on. They create a graph that looks like this one that's on your paper. It's also known as a parabola. It makes this pretty little U shape. And there are parts of the parabola, or parts of a quadratic we need to learn. So we're going to do vocab first. So these points right here, where your parabola crosses the x-axis, it's got several different names. Sometimes they're called roots. Sometimes they're called zeros. Sometimes they're called solutions. And sometimes they're called x-intercepts. They all mean the same thing. They all refer to the same part of the quadratic graph, but they're used interchangeably. Sometimes when you're asked to solve a quadratic, somebody will just say, what's the solution? Sometimes they'll ask for, what are the roots of the quadratic? Sometimes they ask for the zeros, but they all mean the same thing. They are the points where your quadratic crosses the x-axis, and there are usually 2. Sometimes there's only 1, and sometimes there aren't any at all, but usually there's 2. There should never be more than 2 if you're dealing with a quadratic, but there could be 0, there could be 1, or there could be 2 of those happening on every quadratic. This right here, this little speech bubble, is pointing to this imaginary line that is right here. I'm going to draw it in. I'll make it green. Is pointing to this imaginary line that runs right here, right through the center of the parabola, and it cuts the parabola in half. And that line is what we call the axis or line of symmetry, because it cuts it in half and it makes the parabola exactly symmetrical. This right half of the parabola looks just like the left half of the parabola. It's like the mirror that makes the reflection of the parabola. And it always cuts it in half. It always goes right through the middle. And then this point down here that is right in the very center is what we call the vertex. Sometimes the vertex of our parabola is what we call a minimum, like this one is, and then sometimes that vertex is called a maximum if it happens to be at the top of the parabola, and we're going to discuss the difference. And so we have some words down here that we're going to talk about specifically that have to do with this parabola that's on your page, and the first one is this thing called concavity. Concavity of a parabola just talks about which direction the parabola opens. Well, this parabola has arrows that are pointing up, so it opens upward, so this parabola is concave up. Now, as for the domain and the range, I know it's been a while since we've talked about domain and range, but we're going to review. Domain, if you will remember, is all of the x values that a certain function covers on a graph. And so we're looking from left to right when we're talking about domain and range. Well, this parabola endpoint on the left-hand side has an arrow that is pointing and going on forever and ever. And on its right-hand endpoint also has an arrow that points out and goes on forever and ever. So this parabola goes to the left forever and to the right forever. So its domain is, just remember, what we call all real numbers, because it goes from negative infinity to positive infinity. So it covers every number possible. The range is our y values. And so when we're doing the range of a parabola, we're going to start at the bottom of the parabola and go to the top of the parabola. Well, the bottom of this parabola happens to be down here at y equals -4. And from there, it just gets bigger because it is concave up. So when we write our range for this, we're just going to say that y is all numbers greater than or equal to -4, because it starts at -4 and just gets bigger. So turn the page, open up to the inside, and we're going to start talking about the vertex of a parabola. How do we find the vertex? Where's the line of symmetry? Is it a minimum or a maximum? All of that stuff. And so all of this is real easy if you've got a picture like we do for number 1 and 2. First of all, here's our equation, x squared minus 4x plus 2. This is a quadratic equation because it has the x squared as its highest exponent, its highest degree. And when I graphed it, it made this pretty parabola here. So the first thing we're asked for is the vertex. Well, the vertex is right here. And so if I look for that ordered pair, it looks like that ordered pair is at 2, -2. So my vertex is at 2, -2. My line of symmetry, remember, goes right through the center of that parabola. It cuts it in half, and so it actually goes directly through the vertex. And so my line of symmetry for that graph is going to be this line, and since it's a vertical line, it's going to be x equals, and since it goes right through my vertex, it's just going to be the x coordinate of my vertex, which in this case is x equals 2. As that line is at the point where x equals 2. That's where it crosses through the x-axis. Now, is it a minimum or a maximum? Well, if we look at our parabola, it starts up here, curves and hits a bottom point, and then turns around and goes back up. So this is the minimum value. It's the lowest point. So my vertex is definitely a minimum. My arrows are pointing upward, so my concavity is up. And then my domain, it's a parabola, and because it has arrows on the ends of as the endpoints of the parabola, my domain is going to be all real numbers. That will be the case as long as you have arrows as the endpoints. If I suddenly take off the arrows and make actual dots and make actual endpoints, then your domain will change. But as long as they're arrows, your domain's all real numbers. Your range goes from the bottom of the parabola to the top. Well, the bottom of this parabola, since it's concave up, it has a minimum, is down here at my vertex 2, -2, and so it starts at -2 and then just gets bigger. So my range is everything greater than or equal to -2. So here's this second one. The second one is the same exact problem, except all I did was I took the equation and made it a -x squared minus 4x plus 2. And so when I made it -x squared, it has now flipped my parabola upside down. It's now backwards. So here's my vertex right here at this point. And if I go to write down that ordered pair, it looks like it's at -2, +6. And my line of symmetry, which goes right through the middle of that parabola and cuts through my vertex, is going to be an equation that says x equals, and in this case, x equals that x value of my vertex, which is -2. And this time, my vertex is a maximum because it's the very top point of my parabola. It looks like the top part of a roller coaster, like you're riding the Titan, and so you go up here, you get to the maximum, and then it takes off and drops you down to the ground. It has a maximum. This one, since the arrows are pointing down, has a concavity that's down. And my domain, since I have arrows as endpoints, even though it is pointing down, is still going to be all real numbers. Now my range this time, it points down forever, and then it goes all the way up here to +6 for my other y value. So this one, since it's concave down, my arrows are pointing down, is going to be all numbers less than or equal to 6. So I'm starting at my vertex and it's going down. So it goes from 6 and gets smaller. So let's talk about what the quadratic parent function looks like. We have talked about one other type of parent function before today. We talked about the linear parent function. A linear parent function is the y equals x, and remember it's a straight line, and it is that equation that we based everything off of. Well, quadratics have a parent function as well, and in quadratics the parent function is y equals x squared. Parent functions are always positive. You will never have a parent function that is negative. And so it's just going to be x squared. There's nothing extra added to it. It's just y equals x squared. And so if I fill in my table based on this, I will plug in my numbers. -3 squared becomes +9 because -3 times -3 is +9. If you're going to type that in your calculator to double check me, please make sure you put your -3 all in parentheses. If you don't put the negative and the 3 in parentheses before you square it, it will give you a different answer because it thinks you're asking for something different. So then when I do -2 squared, that's going to be 4. -1 squared is 1. Then this is 0, 1, 4, and 9. And so hopefully you notice here, you should be able to see the symmetry happening with this parabola because it goes 9, 4, 1, then 0, then 1, 4, 9. So it's getting smaller to 0, and then it repeats itself in reverse order because now it's getting bigger. So I'm going to plot these points so I can make my graph. So I have -3, 9, -2, 4, -1, 1, and then it's symmetrical on the other side. And so when I draw my parabola for my parent function, it looks like this. Its vertex is at the origin, so it's at 0, 0. And my line of symmetry that cuts it in half, the line that goes directly through the center of that parabola, is right here. It happens to be the y-axis in this problem because my vertex is at 0, 0. So my line of symmetry is x equals 0. So that's the x value of my vertex. The domain is all real numbers because I had arrows on the end. And the range, it starts at 0 and gets bigger, so it's going to go greater than or equal to 0. Its vertex is a minimum because it sits at the bottom of the parabola, and it is concave up. So this is what the parent function looks like, and when we start talking later about shifting our function around, and so transforming it and translating it and all of that, everything will always be based off of that parent function. So y equals x squared, your parent function, that's what it looks like. So now let's talk about the standard form of a quadratic function and then how to find the line of symmetry if you don't have a graph, and then we'll be done with this day. And so here's your standard form of a quadratic. It's y equals ax squared plus bx plus c. We probably have talked about this a little before because every time we factored something, we did a times c to figure out what that number was. So these two questions here, they are asking me to put them in standard form. So I want them to look like this. I want them to go x squared, then x, then c with the y by itself. So over here, my y is positive in number 1. So I want to get this 3x squared away from it and to the other side. So to cancel it out, I will do minus 3x squared on both sides. So it cancels here, so I just have the y left. And then over here, I've got to put it in order. Well, the x squared term comes first, so I have negative 3x squared because I subtracted it, and I had nothing to subtract it from. And then I have minus 5x because that's what was there before, and then plus 4. This is now in standard form. A is negative 3, B is negative 5, and C is 4. So now this problem, negative x squared plus 3 equals 7x minus y. Well, I want this y by itself and I want it to be positive. So right now it's a minus y. I want it to say plus y. So I'm going to add y to both sides so that I can have that y as a positive. So I've got y minus x squared plus 3 equals 7x. So now I've got to get all of this other stuff, this minus x squared and this plus 3, to the other side. Well, to get rid of the minus x squared, I'm going to add x squared. And to get rid of the plus 3, I'm going to subtract 3. So these will both cancel. But over here, I also have to do plus x squared and minus 3. So when I write my equation in standard form, I've got y equals, the x squared comes first, so it's positive x squared, then the 7x, and then the minus 3. So there is that problem in standard form. So now let's talk about finding the line of symmetry from a graph or from an equation if I don't have a graph. And so we've talked about some of this already. We have done this. We walked through this as we did this before. So we're going to do this first one. The vertex right here is at negative 2, 2. And I told you earlier, then the line of symmetry, which goes right through the middle, is the x value of that vertex, which happens to be negative 2. If you need to draw in your line of symmetry so you can see where it is, go for it. And you should be able to see that it crosses right through where x equals negative 2. But then they give me a function, and so they tell me that the function, the equation, is negative 2x squared minus 8x minus 6. Based on that equation, a is negative 2, it's this number in front of the x squared, and b is negative 8, the number in front of the x. Well, then I'm going to use this, do this formula, this opposite of b over 2a, this negative b divided by 2a. Well, negative b, or the opposite of b in this case, would be 8. And 2a would be 2 times negative 2. Well, if I simplify this down, I get 8 over negative 4. And if I do 8 divided by negative 4, I get negative 2. Hopefully, now you notice that this is the same thing as this. That's because my line of symmetry is always the x value of my vertex, but if I don't have a picture to find my line of symmetry, I use this formula. So the equation for the line of symmetry is x equals, it's always x equals. Your line of symmetry will not be any other form. It will be x equals, and it's always going to be the opposite of b over 2 times a. So if you have your quadratic in standard form, you just locate a and b and then you plug them in. So number 1 here, pardon me, I have y equals 2x squared plus 12x minus 7. And so I've got this in standard form. This is a, this is b, and this is c. So I'm going to do my formula, x equals, the opposite of b in this problem is not going to be 12, but negative 12, as I have to change the sign, over 2 times a, and a for this problem is 2. So I'll simplify. This becomes negative 12 over 4, and negative 12 divided by 4 becomes negative 3. So the axis of symmetry for that problem is at x equals negative 3. That gives me another piece of information, though. If you'll remember from up here in this picture and the ones we did before, that axis of symmetry equation is always the x value of the vertex. And so what I know right now, I don't have to do anything with it at this moment, but I know that if I needed to find the vertex of this parabola, I know that the x-coordinate of it is at negative 3. So I could use that to help me find the y-coordinate if I needed to, but we don't need to yet. That's all we need to know. The axis of symmetry is at x equals negative 3. That's where it gets cut in half. So now look at number 2. This is not in order, so it's not in standard form because I got 4x plus x squared minus 8. So step 1, I got to rewrite it in order. So it's going to become, and I'm going to write it up here, y equals, remember the x squared has to come first, then the x, and then our minus 8. And so we'll label my a for this problem is 1, because remember there's an invisible 1 in front of that x squared. My b is 4, my c is negative 8. So I'm going to go to my formula for axis of symmetry, which is x equals the opposite of b, in this case, is negative 4, over 2 times a, which is 1. And then I'll simplify, so I get negative 4 over 2. And when I divide that, I get negative 2. So my axis of symmetry for this parabola is at x equals negative 2, which also tells me that the x-coordinate of my vertex is negative 2. That is our first day of parabolas. Hopefully you got some vocabulary, you've learned some definitions, you can locate some things and find a vertex and an axis of symmetry. We'll practice this tomorrow. I'll see you then.